Hello, everyone. Oh, wrong slide. Hello, welcome to day 6 combinations. Today we're going to be finding the number of combinations of items. This is going to be similar in a way to permutations, just another way of counting things. And it's ironic because you see over that picture, it's called the combination lock, but in fact, it is not a combination. It is a permutation, and you're about to see why. So in our warm-up today, Robbie is that's supposed to say at Domino's Pizza, and he's ordering a 2-topping pizza. Toppings he can choose are sausage, pepperoni, and mushrooms. And each topping can only be used once. That's a key word there. Create a tree diagram to help count the different pizzas that Robbie can order. Okay, so we're gonna go refresh back to day 1 tree diagram. So we have the first topping, second topping here. We can either have sausage, pepperoni, or mushrooms. Those are the highlighted blue words up here. Okay, so if we have sausage on the first topping, our second topping could either be pepperoni or mushrooms. We cannot have another sausage because it says each topping is only used once. So I'm just going to erase what I just wrote there because we know we can't have that. Same thing for the pepperoni first. You can have sausage or mushrooms. Same goes for the mushroom first. And then our different possible outcomes here. Outcomes. Can have sausage pepperoni, sausage mushroom, pepperoni sausage, pepperoni mushroom, mushroom sausage, and mushroom pepperoni. Okay, so we have all of our different outcomes, but with combinations, you're going to learn that you can't have, order does not matter in this case. So for instance, we can cross out, so we have sausage and pepperoni, but then we also have pepperoni sausage. That's saying that we can cross out this because it's equivalent to one another. So sausage pepperoni equals pepperoni sausage. So I'm going to do the same thing, for instance, for this mushroom sausage, because we have it up here as sausage mushroom. Sorry, it's kind of a tongue twister for me. And then the same down here for mushroom pepperoni. So that might be kind of confusing, but we only have 3 total options here. 1, 2, and 3. This picture I'm about to draw up here of these different pizzas might help you understand this. So we have 3 pizzas. Those are the 3 circles. Let's say these green dots I'm putting are representing the sausages. So we have how many total? We only have 2 pizzas with sausage in it. So I'm going to do little sausage dots just in 2 pizzas. Okay, let's say these blue is going to represent our pepperoni. We only have 2 pizzas with pepperoni. So we have a sausage pepperoni, and then we have a pepperoni mushroom. So that's this one down here is pepperoni mushroom. Now, I'm going to do purple to represent our mushroom pizzas. And we have 2 pizzas with mushrooms on it. So I'm going to put our dots. So these drawings of pizza are to help you realize that order does not matter of how the toppings are put on the pizza. It does not make them different pizzas. Okay, so combination definition, you're going to make sure you want to write this down. Feel free to pause it. Combination is an arrangement of R objects without regard to order. So order does not matter in this case, and it has without repetition. And you're selecting from n distinct, so n and r are going to be the same exact things again like they were when we did permutations, but instead, here's our new formula. Before it was NPR for permutation, and it was n factorial over n minus r factorial. But this one, slightly different. As you see here, there's an r factorial here. That's the only part that's missing. That's different about its formula. But that's just the formula, but we're going to go through some examples and reason through it. Okay, so let's say Kate has 4 movies: Avengers, Jurassic World, Toy Story 2, and Lion King. So she's going to pick 2 movies. So we're going to go back to what we did for our permutations and draw our 2 different space values. So our first movie, our second movie. If there's 4 total movies, we can have 4 movies to pick from for that first spot. If this is going to be our permutation again. And then there's 3 for that second one, because if we already picked, let's say we picked Avengers, we only have 3 to choose from if we already picked Avengers. Okay, so then that gets you to 12, but that's our permutations. That's not a combination. And now we know our N. What's our N? We have a total of 4 movies. Our R is we're picking 2 of those movies. But now the new part, this is what the part that's different, is that we have to divide it by, we have to take our 12 permutations. I'm just going to do so that means permutations, and divide it by the number of ways to arrange them. What I mean by them, I mean our 2 movies that we're picking. Two movies. So we have 2 factorial. Because if you arrange 2 movies, let's say we have our first movie and our second movie, the only other way it can be arranged is second and then first. So that's 2 different ways. 1, 2. Another way you can think of it is as our permutation. I think we have 2 spots. There's 2 spots for the first one. And if we already picked one, there's only 1 spot for the second one. And that's the same thing as saying 2 factorial. So our ending result is just going to be 12 divided by 2. Remember, our number of permutations, 12, divided by our number of ways to arrange those 2 movies, because order does not matter in combinations. Again, feel free to pause it, rewind it. We're going to keep moving forward. So now, a committee has 8 members. How many different ways can a president be chosen and a vice president be chosen? Okay, in this case, let's think, does order matter? Well, we have 2 different roles, so president and vice president. So our order is going to matter. Order matters. And since order does matter, we know it's a permutation. So because we have a spot for pres and then VP. We have 8 total people, so we know it's going to be 8 choices for that first spot. And then for our second spot, we know there's 7 because we already picked a president. And that's 56 ways. And that's a permutation, because order does matter. We'll go more into this in the next lesson, but this is just going to be kind of a brief summarization of how to differentiate the 2. And how many ways can 2 senators be chosen? Let's see, does order matter? If they have the same role, order does not matter. And this is a combination when order does not matter. This is what we learned about today. So we have, remember our number, its combination is number of permutations over number of ways to arrange the 2 things being selected, because we have 2 senators. If it was 3 senators, it'd be number of ways to arrange the 3 senators on the bottom. So we have a pres and VP. That's a V. And again, we have the 8 times 7, because that's the same as the above, 56, over, and then we have to arrange, how many different ways can we arrange the 2 senators? And that's just 2 factorial. If it was 3 people, it'd be 3 factorial. So 56 divided by 2 is going to get you to 28 different ways. And then how are they different? Well, one, order does matter, and the other, order does not. And then we'll go into more depth of it. So, and you can see that there's more outcomes in the permutation than there was in the combination. Remember, order matters in the permutation, and order does not matter in the combination. So now, again, this is just permutation versus combination. We're going to go more into this, into more depth in the next lesson. But just keep in mind, permutations, order matters, and it's going to be, permutations are like president type problems that we just did. So like president permutation, like when they have different roles versus a combination, when order doesn't matter, because if you're assigning roles that are the same, like a committee, like combination, committee, the order does not matter. And again, remember that your homework and homework quizzes are on Schoology. Be sure to check off your little attendance form and email if you have any questions. Thanks.